Imagine sitting on a plane waiting to take off. You hear a deep roar. The jet engines are waking up. They are powerful machines, built to move hundreds of tons through the sky at nearly the speed of sound. But what really happens inside those metal giants hanging under the wings? The story of jet engines is one of science and engineering working together. Jet engines do more than just push planes forward. They must work in freezing air, at high speeds, and for hours at a time, without stopping. Safety and reliability are not just important, they are everything. If a jet engine fails, lives are at risk. That's why engineers spend years perfecting every part inside. Inside a jet engine, temperatures soar hotter than a volcano. The spinning blades move faster than a race car. The metal must be tough enough not to melt, crack, or break. Every section of the engine faces its own set of challenges. This is what makes jet engines so fascinating. In this essay, we will dive into the secrets of jet engines. We'll explain how they work, what makes them so strong, and why their design is crucial for safe flight. By the end, you'll see why these machines are one of humanity's greatest inventions. At its core, a jet engine is simple. Air goes in, energy is added, thrust comes out. Let's break that down step by step. First, the engine takes in air through the front fan. This is the start of the journey. Next, the air moves into the compressor. Here, spinning blades squeeze the air tightly, like packing a spring. The more you compress the air, the more power you can get from it later. After compression, the air is very hot and under high pressure. Now comes the most exciting part: combustion. Fuel is sprayed into the hot, compressed air and set on fire. This makes the air expand quickly. The expanding air rushes past the turbine, spinning it at incredible speeds. Finally, the hot air shoots out the back of the engine. This pushes the plane forward thanks to Newton's third law. Every action has an equal and opposite reaction. That's how thrust is made. With these steps, intake, compression, combustion, turbine, and exhaust, the engine turns fuel into forward motion. Look at a modern airplane. The engines are huge, sometimes bigger than a car. Why are they so big? The answer is the turbofan design. Instead of moving a little air really fast, turbofan engines move lots of air slowly. This is called a high bypass ratio. Most of the air goes around the engine core, pushed by the big front fan. Only a small portion goes through the burning high-pressure center. Moving more air at lower speed is better for fuel use and makes less noise. Think of it like rowing a boat. Paddling gently with a big oar moves more water, and you glide smoothly. Paddling hard with a tiny oar splashes more, but you don't go as far. Jet engines row through the sky with big fans, which is smarter and more efficient. So big engines mean quieter flights and cheaper tickets. Airlines love that. Passengers do too. That's why the massive, high-bypass turbofan is the engine of choice for modern airliners. Inside a jet engine, things get extreme. Air rushes in at hundreds of miles per hour. Once compressed, it faces temperatures hot enough to melt steel. The spinning parts, like the fan and compressor blades, travel so fast, their tips can break the sound barrier. Each part of the engine has a special job. The compressor must squeeze air more than 30 times tighter than the outside air. The combustor must burn fuel cleanly, without making too much smoke or heat that could damage the engine. The turbine, just behind the combustor, has the hardest job of all, spinning at over 10,000 times per minute while being blasted by hot gas. All these parts are under enormous stress. The pressure inside the engine can be up to 40 times greater than outside. The temperature can be higher than the surface of some planets. Only the very best materials and designs can survive. Failure is not an option. If a turbine blade cracks or a compressor stalls, the engine could shut down. That's why every engine is tested and checked, again and again. Reliability isn't just about good parts. It's about making sure they work together perfectly, every single flight. So normal metals would, just melt or break under jet engine conditions. That's where superalloys come in. Superalloys are special blends of metals designed to handle heat, stress, and corrosion. Nickel is the main ingredient, joined by elements like chromium, cobalt, and aluminum. But what makes superalloys so strong? Well, it's all about these tiny building blocks inside, called crystals. You can imagine a metal as a grid of atoms, all lined up. But when metal bends or gets hot, those atoms can slide out of place. This is called dislocation. Superalloys are built to stop those slips. Engineers add certain elements that lock the atoms in place. It's kind of like putting extra beams in a building to keep it strong during an earthquake. The more you can control these slips, the stronger and tougher the metal becomes. Superalloys are honestly a miracle of material science. They let turbine blades survive heat and stress for thousands of hours, something plain steel or aluminum could never do. Without superalloys, jet engines simply wouldn't fly. Turbine blades are the heart of the jet engine. Making them is, well, both a science and an art. The process starts with investment casting. Here's how it works. Engineers create a wax model of the blade and cover it with a ceramic shell. When the wax melts away, it leaves a perfect mold. But there's a twist. Inside the mold, the metal is cooled in a very special way. Engineers actually grow the blade as a single crystal, with no grain boundaries. This is called single crystal casting. Grain boundaries are weak spots where heat or stress can cause cracks. By growing blades as one large crystal, those problems just disappear. Imagine a garden path made of bricks. If the path is all one piece, it's hard to break. If it's made of many bricks, cracks can form between them. Single crystal blades are like that one-piece path, strong, smooth, and tough. Single crystal casting is slow and expensive, but honestly, it's worth every penny. These blades turn at 10,000 revolutions per minute in air as hot as lava. Only the best blades survive. How do turbine blades handle such crazy heat? It's not just the superalloy. There are three big secrets: alloys, coatings, and cooling. First, the superalloys themselves resist melting, but even they would fail without help. Second, engineers add special ceramic coatings to the blades. These coatings act like sunscreen, reflecting heat away and protecting the metal underneath. Without coatings, the blade surface would burn up in minutes. Third, the blades are hollow, with tiny channels inside. Cold air from the compressor is piped through these passages, cooling the blade from the inside out. It's kind of like running cold water through a hot frying pan to keep it from overheating. Together, these tricks let turbine blades survive temperatures higher than their own melting point. It's honestly one of the coolest feats in engineering, literally and figuratively. Jet engines are built for people, by people. Every part is designed, tested, and checked by teams of skilled engineers and technicians. They use computer models, wind tunnels, and real-world tests to make sure every engine is safe. Safety is always the top priority. Modern jet engines almost never fail. This reliability is the result of years, sometimes decades of careful work. Every new design is tested for thousands of hours before carrying passengers. Innovation never stops. Engineers are always looking for new ways to make engines quieter, cleaner, and stronger. They use 3D printing for parts, experiment with new materials, and run engines hotter and more efficiently than ever before. All this work pays off in the sky. When you fly, you trust your life to these machines and the people who build and maintain them. Jet engines are a true team effort. Jet engines are more than machines. They are the reason we can travel the world quickly and safely. Each engine is packed with science, from the way air is compressed and burned, to the metals and crystals that stand up to heat and stress. The secrets inside jet engines, superalloys, single crystal blades, cooling tricks, are what make modern flight possible. Without them, planes could not fly as far, as fast, or as safely as they do today. Next time you board a plane, think about what's happening under the wing. There is an entire world of science and engineering at work, all for one purpose: to keep you flying safely above the clouds. That's the power, science, and secret inside every jet engine, a true wonder of the modern age.